Okay, before we start talking about geometric mean, let's talk about the different parts that are in a right triangle. In this right triangle, my legs are two different sizes. So I'm going to call one leg the large leg. I'm going to call the other leg the small leg, because it's smaller than the large. My last side of the triangle, that is opposite my right angle, is called my hypotenuse. My hypotenuse is always the longer side of a right triangle. So if I were to draw a line from the vertex that contains the right angle all the way down to the hypotenuse, if my line is perpendicular to the hypotenuse, this line is called the altitude. So instead of calling the bottom the hypotenuse, let's call it the base. Because I have my altitude drawn in there, my base is now split into two different parts. Since one is larger than the other, I'm going to call one part the large part, and I'm going to call the other one the small part. So now let's use all of this information to find the geometric mean of the triangles. So for this first triangle, they give me the altitude, which is 18, so I'm going to use the geometric mean for altitude. In this case, we're going to start out where it says part of the base. So I chose Y to be part of my base. You can choose 12, it doesn't matter which one you choose, because you're still going to end up with the same answer. So I have part of the base over my altitude, which is 18, equals my altitude over the other part of the base. Since I chose Y to be the first part, my next part is 12. To solve for this, all I do is cross multiply. So 12 times Y is 12Y. And then I take 18 times 18. When I simplify that, I have 12Y equals 324. And to solve for Y, I need to divide by 12. Dividing by 12 cancels these out because 12 divided by 12 is 1, leaving me with just Y. 324 divided by 12 is equal to 27. So Y is 27. In my next example of using the geometric mean, they give me a leg. So I'm going to use the geometric mean for a leg. In this case, they give me the small leg. So let's just plug in our numbers to our equation. So our equation for the geometric mean for a leg is the whole base over small leg equals small leg over the small part of the base. So my whole base is represented by this whole distance here, or Z. My small leg is represented by the 27. So Z over 27 equals 27 over the small part of my base. In this case, it's 16. To solve for this, just like the other one, we just cross multiply. 16Z equals 27 times itself, 27. So when I simplify that, 16Z equals 729. To get Z by itself, I divide by 16. I have to divide both sides by 16. This leaves me with Z by itself, and my answer is about 45.6. So z is equal to about 45 6/10. My next example of geometric mean is very similar to the last one. Instead, in this case, they give me the large. They're asking me for the large length, sorry. So I need to just follow exactly what the equation says. The whole base, which is this whole distance, is 8. So whole base over the large leg, which we don't know what it is yet, so it's represented by x, equals x over. Now I need to find the large part of my base. I don't know what it is yet, but I do know the whole base is 8, and I know a portion of it is 2. So I'm just going to subtract those two, and that gives me the other part of my base. So the large part of my base is 6. Just like in all of these others, with our proportion, we are just going to cross multiply. So x times x is x squared, and 6 times 8, when I simplify this, ends up being 48. So x squared equals 48. In order to get the x by itself, I need to do the opposite of squaring it. So since this is telling me to square, the opposite of squaring something is taking its square root. So those cancel each other out, and all I'm left with is x. So x is equal to about 6.9. If I wanted this in radical form, what I could do is take the square root of 48 and break it down using prime factorization. So 48, I can take 2 times 24. 2 is a prime number, so I'm going to circle it. 24 I can break down. 2 times 12. Once again, 2 is a prime number, so I'll circle it. 12 I can break down to 2 times 6. Whoops, circled the wrong number. And 6 I can break down to 2 times 3. Now that I can't break it down anymore, I'm going to look at all of my prime numbers. Every time I have 2 of the same number, I'm going to cross them out and pull it out to the side. In this case, I have a group of 2's. I have another group of 2's, so I'm going to multiply that by the other 2 that I have. 3, however, is by itself and it doesn't have a partner, so 3 has to stay inside the square root sign. Now all I do is what it says. 2 times 2 is 4, square root of 3. So this is your answer in radical form.